Welcome to a new video. In this episode I'm going to show you how to install Frigate standalone on a single board computer running Ubuntu, how to configure it to start recording on an external USB drive with person detection enabled. For those of you who haven't heard about Frigate, it's an open source NVR with real-time AI object detection. It's built in, it has all recording and processing happening locally on your own hardware, so a good thumbs up for being open source. We love open source project on the Voltlog channel, but another thumbs up is for hosting everything local, so you have security and privacy under your own control. You can run Frigate on a variety of hardware options, including your home assistant server if you wish to do so, but some people might opt to run it independently on another computer for increased processing power and or more storage options. For this tutorial I'm going to be installing it on the Khadas VIM4 single board computer, and this thing is a beast. I'm calling this the Pi Killer for reasons which I will outline in a few moments. This was released in this summer. It's the latest model in the Khadas Vim lineup and comes with some stellar specs. This has an 8-core Amlogic A311D2 processor. 4 of its cores are ARM Cortex-A73 running at 2.2 GHz. The other 4 are Cortex-A53 running at 2 GHz, and there's an extra 32-bit STM32 microprocessor on this board. There is a powerful Mali G52MP8 GPU inside this processor, which supports up to 8K decoding. We have 8 GB of LPDDR4X RAM, 32 GB of eMMC storage, 32 MB of SPI flash memory, which runs its own custom bootloader called OWOW. It has Bluetooth and Wi-Fi 6 connectivity plus a 10 gigabit Ethernet connection. There's also an M.2 slot for SSD on the back, and the list goes on and on. They practically jammed everything that's nice on this board, and out of the box it can run Ubuntu and Android. Now you're probably asking yourself, how does this stack up against the Raspberry Pi 4? So here's a simple comparison sheet just based on their specs. If we look at the processor power, RAM memory, storage options, connectivity, the VIM4 clearly has the edge here, and it has more horsepower than a Pi 4. The only place where the Pi 4 has more options is with the USB connectivity. Now, having all of this extra horsepower on the VIM4 does come at a cost, and the VIM4 can get pricey, especially if you order it with the active cooling kit, which is not included by default, but you will need it if you plan to benefit from that processing power. For the latest price information, please check out the links I've placed in the description of the video. We could also talk about availability, with the VIM4 being available for ordering right now from Amazon, while the Raspberry Pi 4, it's kind of hard to find. So due to the VIM4 processor being manufactured on a 12 nanometer process, we can also expect better power efficiency, providing more performance per watt over the Pi 4. Another impressive feature of the Amlogic processor is the built-in neural processing unit, which is rated for 5 TOPS, and by comparison a Google Coral is only rated for 4 TOPS. But as we all know, a Google Coral is well supported over many different interfaces, while the new NPU inside the Amlogic processor is there, I think, but not actually supported in the software due to license requirements which are not yet sorted. So in the end, even though the Amlogic processor advertises that feature, you'd be better off with just buying a Google Coral if you can find one. Now, before I continue, let me mention the sponsor of this video, PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. Right now they're running their 5th annual PCB design contest, so if you have some PCB designs that you'd like to submit, why not do it for a chance to win one of the juicy cash prizes. You could also try them out for many of their other services like 3D printing, CNC machining and manufacturing services in general. Check out their website, linked below. So you have a few different options for loading an operating system onto this board, but since we have that fast and reliable 32 GB eMMC storage on board, we're going to install our operating system onto that. Now luckily Khadas have made that job extremely easy for us, because they are running their own custom bootloader, which is called OWOW. This bootloader is stored on the onboard 32 MB flash memory, so even if you break something in the eMMC image, there is still an easy way to recover by jumping into the bootloader. And upon starting into the bootloader with just a couple of options, you can have it connected to Wi-Fi and you can pull the latest available operating system images directly from their servers over the internet. You don't have to prepare an SD card, download an image, flash it with a special tool like you would have to do with pretty much any other single board computer, Raspberry Pi included. And to make things even nicer, they've even built this web interface mode where the board can run in a hotspot mode and you can connect to it, access it over the local network, so you don't even need a mouse, keyboard and monitor setup plugged directly into the board. So I'm going to use this feature. It makes my life much easier if I don't have to plug a bunch of peripherals into the board. I went with Ubuntu 22.04 for this tutorial and it took maybe 15 to 20 minutes to have everything installed and booted into the new OS. Default password is Khadas, so I was on my way of setting up Frigate in no time. One thing I would recommend is that you use a good quality USB cable and a good quality 3A rated USB power adapter to power the Khadas board, because you can easily get brownouts if it doesn't get enough juice. There are also other power options available, but I won't go into those details in this video. I'm just going to power it over USB-C. Now, once we have Ubuntu up and running, there are a few steps to follow to get Frigate installed and configured. For the remaining part of this tutorial, I will be connecting via SSH to run commands in a terminal. And first, if you plan to use an external USB drive like I am for storage, the first thing to do is to format it as a FAT file system from another machine. You could also do this from Ubuntu itself, but I just find it easier to plug this into my Windows machine and format it as exFAT. Then I plug it in and mount it inside the Ubuntu operating system on the VIM4. After plugging in the USB drive, I run this command fdisk-l to see a list of available drives, and your external drive should show up as /dev/sda or something similar. Now you have to create a new directory where you will mount the external drive, and I chose to mount mine in a /media/SANDisk. So I created that directory using the make-dir command, and next, using this command, I mounted the drive we found earlier into the newly created directory. And if your drive is not formatted as FAT, you'll have to supply other arguments to this command, other parameters to specify the file system type. That's why I recommended to go with FAT, because there is no extra parameters required. Now, using this command, we can check our newly created storage option, which is mounted in the OS, and first step is complete. All of the commands shown in this video will be placed in the description below, so you can copy and paste them. I might also do a blog article to outline the steps shown here. Step number 2 is to get Frigate and Docker set up. The easiest way to run Frigate is with Docker in a container, and you have to start by setting up Docker, and to do that you run these commands, which are used to get the latest repository information, and then add the Docker source URL. Then using these commands we get Docker installed and we then start it. Now would be a good time to check if Docker is running okay, and you can do that with this command. It's docker run hello-world, which should output something like this, and as the text shows, this performs a number of steps that prove Docker is running fine. At this point, you could also install Portainer if you'd like to have like a graphical user interface to manage your Docker instance, but it's not really required. It's not the purpose of this tutorial. Step number 3 involves basically installing Frigate and configuring it for our needs. This isn't necessarily a user-friendly step because it involves writing the config in YAML format. There isn't a GUI config option available, and I don't like complaining about documentation of open source projects because the authors of these projects are already doing a lot by releasing these as open source projects, so it's understandable if the documentation lags behind. And at the very best, instead of complaining, I could just start helping to improve the documentation myself. But I'm going to mention this. The documentation assumes you already know a lot of stuff about how these things work, how Docker works, and I believe this keeps a bunch of people away from Frigate, people that would be fine with a detailed step-by-step guide, but not with one that assumes they already know a bunch of stuff. So I started by creating a directory to hold everything. This is in my home directory path. Next, we need to create a file name frigate.yaml, which will hold the Docker compose setup config. This is a set of instructions for Docker on how to bring up a container with Frigate. The only thing you need to edit in these files are the image type. In my case, I had to select Frigate stable Arch64. This is according to the hardware that you're using. Next, I edited the path for the Frigate config file, which we'll create soon. Section on the left is the actual path on the disk. Section on the right is the mounting path inside the container. So I changed the section on the left to point to the location where we will be storing that config file. Additionally, because I want to record on an external USB drive, I also defined the path that we mounted earlier here. Everything else stays at default settings for now. Next, we create the config.yaml file, which is the actual configuration file for Frigate. This will hold your general Frigate and custom camera settings. There can be many options that you set from this file, but we'll start with the basic file, which will need to contain the MQTT server details. This can be the MQTT server from your Home Assistant instance, or you can just set up a separate local MQTT server running on the same computer as Frigate. This file will also contain a minimum of one camera setup with its record and detection settings. As you may have noticed, I have the general record settings enabled with a retain policy of 2 days for all cameras. Please note that Frigate does not have a limit on how much disk space it uses. It will continue to record based on your settings until it uses up all of the available space, at which point your operating system might stop working. So extra care should be taken to ensure your recording policy has enough disk space available for the settings. For the camera setup, I just provided the camera RTSP feed with a username and password combo, and I have two separate H.264 feeds coming out of my camera. I use the lower resolution one for live streaming and detection purposes, while the higher resolution one is used for recording. I also have defined person detection for this camera. This is just one of the many available options. You can also detect like cars, pets, stuff like that. This is a pretty basic config file to get you started. There are many more settings available for Frigate, and for that you'd have to check their documentation. The only thing left to do now is to bring this container up and running with the following command. We're using docker compose -f frigate.yaml up. If everything is correct in your config, then Frigate should be up and running and your terminal will continue to print debug messages from Frigate. The web interface can be accessed using the IP address of your server at port 5000 over a regular HTTP connection. The user interface for Frigate is pretty self-explanatory. There is the camera feed page where you get a live feed. There is the video recording stamp, which seems to be combined with the events it recorded. And by default, Frigate is not password protected, nor does it use HTTPS, but since you're installing this on your local network, it should be behind the firewall, so theoretically it should be safe. Nonetheless, further steps should be taken now to secure this installation so only you have access to it. At this point, it is also possible to integrate the Frigate instance with Home Assistant by installing the Frigate integration on your Home Assistant server, but I won't be covering that in this video. After playing with Frigate for a couple of days, it seems that its person detection is very accurate. At least with my setup, it never misses a person. However, please note that all of this processing happens at CPU level. In contrast, if we were to install a neural processing unit like a Google Coral, CPU usage would go down considerably as the detection algorithms would be processed on the neural network accelerator. Here is, for example, the CPU usage for Frigate running this detection algorithm for one camera at 6 frames per second on the Khadas VIM4. And now the VIM4 is a pretty capable board with all of its 8 processing cores on the CPU, but at some point, if you throw many cameras at it with multiple detection algorithms, high resolutions, it will exceed the capabilities of the CPU. Also, as a downside, there is no support for the Mali GPU inside the Amlogic system on chip, at least not in FFmpeg, so it's pretty much useless for this task. I've been reading various sources that say limited success might be achievable by recompiling FFmpeg with different settings, but I'm by no means a Linux guru, so I won't be going down that path. It's just easier for me to get a Google Coral when they'll be back in stock, because that's like natively supported and it will work with minimal fuss. The Khadas VIM4 is certainly a very capable and versatile single board computer with excellent support from the manufacturer. I mean, just that awesome OWOW bootloader is a feature that would make you want to try their ecosystem, but there are also a few downsides to consider, and these are things that I've just noticed while using the board. For example, the HDMI port is too close to the USB-C port, and because of that some thicker HDMI cables cannot be used. And I don't like the fact that these antennas are external and they use these very tiny IPEX type connectors, which can be very fiddly to connect and very easy to damage with these small connectors if you manhandle them. I would have preferred maybe a slightly larger board with some onboard ceramic or metal antennas. There's also no warning about powering the board without the antennas, but as we all know, that is something that should be avoided in order not to damage the RF front end of the Wi-Fi module. And the fact that this has an active cooling fan can make it noisy, kind of like a small laptop running full load. It can scream when it's running full load, but luckily the fan is actively managed, so it won't be running at full speed all the time. Also, it can be pretty difficult to just plug connectors into this board because there is no place where you can hold it. Like on this side, you'll be breaking the Wi-Fi connectors if you try to hold it. On this side, you have the reset and power on switches. On this side, you have the pin headers, and it can start to act weird if just the simple resistance of your hand is present on all of these signals. So it's kind of hard to handle this board for insertion of connectors. In general, I think all of these problems could have been solved if a slightly larger board was being designed. But in general, these are little things, and in comparison with all of the great stuff this board has to offer, I don't think these things will stop anyone from getting this board. Probably the biggest weakness of this board is its higher cost, but I guess that's the cost you have to pay these days if you want a higher performance single board computer. That was all for today, and I will be continuing to play with Frigate to optimize it with different settings, adding more cameras, adding an external AI accelerator, but I would also be interested in hearing your thoughts regarding this SBC. Frigate in general maybe? Are you using Frigate? How do you like it? Let me know in the comments below, and should you decide to order the Khadas VIM4, you will find a link for this in the description below. Thank you for watching this video, and I will be seeing you next time.